Yes,
So,
sir.
okay, fine.
Sir, I wanted to ask, you
Ah,
forwarded a mail to us.
yeah, yeah,
What does it mean? Like, I understood that the syllabus
yeah,
is still
yeah.
chapter
I'm telling
7.
about that. I'm telling about that now.
Okay.
Regarding your mid exam, so this evaluation will be the central evaluation. That means you all have to attempt only one question paper, which is prepared by all together, all the professors. Okay, concern the syllabus up to this only means second law of thermodynamics. Okay, entropy part as well as control volume means the second law applicable to the control volume that we don't have. Okay, so up to second law of thermodynamics, whatever we have discussed theory part in our previous class and whatever the problems we are solving now and coming to this. Okay, so
So
that is
when
up
will
to
be
the
the
syllabus.
test?
Test also it is written in that only, right? Whatever the window you have, third week. Okay, you have a window, right? A test window from the next week, I think so. Okay, so 21 to 24th or 25th, you have one window, right? Test window, according to the institute academic calendar. Okay, one of the day would be like that. So even though coordinator of this course, Professor Roy, has not yet decided that, once he will decide, then I'll inform you all. Okay, the good thing is that syllabus is up to this part only. Okay, up to this part, whatever the problems we are solving today's class and tomorrow's class. Then later part actually entropy and all are not in the this thing. So what I am thinking after this tutorial, two tutorials in the Friday class, I would like to take another tutorial upon uh, application of first law of thermodynamics upon the control volume. We have solved some problems, but all the problems actually whatever we have solved, we have considered steady state. We have not solved transient problem actually. Okay, that part we left. So I would like to focus upon that also. Okay. Even these all tutorial problems, I am covering both the books, Sontag book and I have Marx books also. Both the books I am covering. And even Sontag book actually we have two different versions actually. Okay. So I'll be dropping that another version also, sixth version actually, sixth edition. Okay. So that also I'll drop to you. Then and also in the Google Drive link is given over there. That Google Drive link is created by Professor Subranshu Roy. Okay, so please follow those also. Once you follow our tutorials, actually in my tutorial, I have covered all the problems of different difficulty levels. Okay, so if you follow our tutorial very well, and if you will be able to understand the concept, okay, then you will be able to answer any type of the question. Okay, so that's what. So please solve our tutorial very well. You try to understand each and every step and yourself you solve some more problems also, then you will be perfectly all right for upcoming whatever the test. Okay. Do you have any more questions regarding this mid exam and syllabus?
Sir, what is the mode of examination?
Pardon?
Sir, mode of examination means
Mode
it
of examination. So it would be, I think so, through the model only. Okay.
Like, sir, will it be like MCQ type or numerical type or like what type of questions?
That also not yet decided actually. Discussions are going. Actually, the thing is that four sections are taking. Four different faculties are teaching and their syllabus also completely different. Somebody may be lagging, somebody may be going ahead. Okay, so we have started discussion from 2 days ago, and then discussions are keep on going. So far, we have finalized the syllabus part. Okay, so good thing is that we are on the track. We are going appropriately according to the syllabus, and still we have one more or two more weeks also. If we are lagging, then we could cover in that time also. But luckily, we have covered all the parts. Okay, once we complete this tutorial part, you all are ready for your test, and even one, as I already told, one more tutorial I will take. Okay, but regarding the test part, actually, what mode of the test, like as you have asked, multiple problems or whatever, multiple choice or that we have not decided. I'll let you know. I'll let you know very quickly by tomorrow. Okay, or day after tomorrow. Okay.
Excuse me,
So,
sir.
yeah, please.
Sir, how many total tests will be there in this course?
Yeah, that is a good question. Actually, this is two exams will be there as like central evaluation. One is this mid exam and another one is the final exam. This is the central evaluation. So in between, actually, our coordinator, Professor Subramsu Roy, has asked us to take additional test. Okay, so I would like to take additional test. That way, actually, we will have some good convenience or whatever we can call to adjust our marks, and then these are all the things actually. So I would like to take another test between your mid exam as well as the end exam. Okay, I would like to take test for our own section. That is third test. Total 3 tests.
Sir, you will tell beforehand or randomly you will take something?
No, not any surprising piece kind of thing. This is the scheduled only. This is the scheduled, and then I'll announce the date after your mid exam based upon your performance in the mid exam. Okay, so obviously that will be like actually you need to give the mid exam pattern would be you need to enter the answer, then spot evaluation would be there. Okay, the model itself will be evaluating you. Otherwise, actually 400 students papers, if we have to correct this, that would be very laborious process for us. Okay, I hope so, but not yet finalized. Let me find out from Professor Roy, and then I'll inform you. Third test will be similar pattern, but only for our section I will take. That we cannot call third tester. Between your mid exam and end exam, there would be another exam which will be taken by me itself for our own section. Okay, do you have any other questions before going to the tutorial?
Sir, what are the weightages of these 3 examinations?
Pardon?
Sir,
Weightage. Okay, weightage. Weightage also not decided. Not decided yet. Okay. So far we have finalized the syllabus part. Okay. So whatever the information I have further from the Subramanian Roy sir, and then I'll forward you. Okay. So the whatever my wish, as you know, everybody should get pass in this particular subject. Okay. I'm telling about poor candidates case. Anyhow, so many students will get EX, A, and B's also. Okay. Usually this fail percentage is little bit high in case of thermodynamics. Okay. So please be careful and read the subject, whatever the presentations I have given line by line, and try to understand the concept. First solve our own tutorials. Okay. If you are not able to understand, and then you can open our video. Okay. Because videos are noted, and try to solve our own problems. Then open your textbook. Attempt many problems are there actually. You can follow any textbook. Okay. That is only based upon the concept, nothing more. Okay. So and then practice ES. Okay. What is the advantage of ES? You have seen. You no need to go and worry about the tables. Okay. So once you enter this whatever enthalpy bracket steam comma P1 comma T to T1, that will be giving you the value. Yes. Yeah. So that would be very advantageous. Even that code also I am giving you for every problem whatever we have solved. That code also I have given you. Okay. So please practice that also. Okay. So in between, if you have any doubt, you can send me mail, or otherwise you can directly write in the Teams. Okay. So if you don't have any questions, then because this is 1 hour class only, let us try to solve our problems quickly. Fine. Okay. Okay. Thank you. So yeah, give me 1 minute. Actually, I forgot to add my this thing. What is that? Animations. Okay. Only 1 minute. I'll quickly add animations and come back to you. Okay. Otherwise, no use of this tutorial, right? So I'm back here. This is problem number 1. So please solve it by yourself. Okay, that would be very helpful to you because exam is coming up. And let me know the result. I'm waiting for you for 5 minutes. Am I audible to you?
Yes.
Yeah.
Yes,
So
sir.
yeah. So this slide is visible to you or not?
Yes, sir.
Okay. Right. Please solve. Okay. So anyone could solve this? Anyone could able to solve? At least A, B. Pardon?
Sir,
Yeah.
So like the efficiency is 5 by 8.
Mhm.
So like the B1 can like is correct according to that,
Ah,
because the efficiency in the B part works in the cycle upon the heat given
okay,
is coming 5 by 8.
okay, okay, okay,
And sir, in the first part, the efficiency is the efficiency is coming out to be lesser than 5 by 8.
okay, okay. So
And
you could calculate the value also, right, by calculator.
yes, sir, yes, sir.
Okay, okay, okay. Correct, correct. Anyhow, okay. Let us see. Okay. So I'm explaining over here. Here actually three different conditions have been given. Completely like what is your heat input? Okay. What is your heat output? Means what is the heat source from the reservoir, hot reservoir, and what is the heat rejected to the cold reservoir. Okay. So in terms of, if you talk in terms of thermal power plant, what is the heat supplying by burning the fuel? Okay. What is the heat rejecting in the condenser? Yes, that is only the cycle, right? Heat supplying in the boiler by burning the fuel, heat rejecting in the condenser section, okay, to condensate saturated steam to the saturated liquid, okay. And because of turbine, because of expansion is taking place, you are getting certain amount of work. That is only listed over here of the power cycle. Here they are saying. Here three different conditions have been given. So whether it is possible or not, that we have to check. Okay. Obviously, this is the heat balance equation. Yes. And the efficiency of the cycle also we are considering work by total heat input. Yes. This is anyhow wastage, right? So that's what work output by total heat input. A. For case of A, once you see this kind of balance, okay. So heat supply minus heat rejection is equalizing with your work output. So it is satisfying, okay. And also the efficiency you are getting 57%, okay. And we need to check whether it is less than the reversible cycle or greater than the reversible cycle or equal to the reversible cycle. What is the reversible cycle? What it means, like what is the maximum possible amount of efficiency can be obtained? That is your Carnot cycle. Okay. So what is the problem with Carnot cycle? That also we have seen. That efficiency is simply defined by the temperature of upper and lower. Yes, upper and means the source temperature and sink temperature. Okay. According to the Carnot cycle, based upon the source temperature and sink temperature, this is the maximum efficiency can be obtained. Okay. So here actually in the problem itself, sink temperature and source temperatures are given. So given in the centigrade, so we have converted them to the Kelvin. Okay. According to that, this formula, maximum efficiency can be obtained is 62.5%. Whatever our cycle is getting 57.1%. That means this is a reversible cycle according to the Carnot phenomena. Whatever our efficiency is there, that is less than that. Okay. That means what it is telling, by satisfying the energy equation, first law is passed. Okay. And by satisfying this efficiency comparison, second law is also applicable. Okay. That is about problem A. So that is the reason we are telling over here. First law and second law both are satisfied. Now regarding problem B, okay, this is the efficiency we are getting from the energy and work. Okay, what does it mean? This is exactly matching with your Carnot cycle. That's what actually in the problem A, the cycle was irreversible cycle. Okay, that is the actual cycle we can call. Here in the problem B, the cycle is a reversible cycle with Carnot cycle. Okay, so maximum efficiency is obtained, but that is also can be acceptable actually. Okay, the cycle efficiency is reached to the maximum, and cycle is the reversible cycle. We can say, we cannot say it is not validating. The problem number C, if you see, the energy balance itself is not matching. Yes, QH minus QC should be 440. Okay, but it is giving you 400. The energy balance itself is not validating. Once first law itself is not validating, then no need to go and check second law of thermodynamics. Okay, that's what C. For case of C, it is not validating, but this is actually actual cycle. This is the reversible cycle. Okay, this is our problem number 1. Do you have any question over here or any doubt? Anyhow, after tomorrow's class, I am sharing this total presentation. Okay, then you can go or otherwise you can solve yourself. Problem number 2. Please read very carefully. Okay, this is problem number 1. Problem number 2. And try to solve yourself. Okay, I think by reading the problem itself, you would have come to an understanding. Okay, here actually, this is a combined cycle kind of thing. This is the hot reservoir. Okay, and here, this is the power cycle actually. Okay, and then this is generating certain amount of work. That work is feeding to certain refrigeration cycle or heat pump. Okay, so here whatever it is giving to the intermittent or otherwise environment, and it is sucking from the QC, okay, and supplying heat to the intermittent stage like this. Okay, so here you need to find out. This is actually understanding the concept. This is not very big problem actually. Many other parameters are given at this stage of considering these many parameters, and again with these parameters. Okay, how to solve that? That is like for a power cycle, as you know, this is power cycle is operating between these limits. Okay, and refrigeration or heat cycle is operating between these limits. We are taking this as the power cycle. Okay, so this is the same time energy balance for the refrigeration cycle is between these two. This is the low temperature reservoir. This is the high temperature reservoir. This is the work we are supplying over here. Okay, so when you are combining both, because this work only coming over here, right? So these two works are same. Yes. So that is the reason when we are combining over here. So these two are equalizing. Okay. Okay. And then we are considering over here. This is the reversible cycle. Yeah. So if you observe over here, power cycle is a reversible cycle. Okay. And refrigeration cycle also reversible cycle. Okay. So then, so we are forming like these equations. Okay. Then finally, this is Q naught by QH. Since it is the reversible cycle we are equalizing with Carnot cycle. Yes. So that is transformed Q by QH equal T0 by TH. Okay. So what is the Carnot cycle efficiency? Eta equal to 1 minus QC by QH. Same eta equal to 1 minus TC by TH. Is it? So in terms of energy as well as means heat energy, in terms of temperatures, both equalize. That way we got this parameter for the heat engine, we got this parameter for the refrigeration cycle. Okay, this is just reformed like this. This is also reformed like this. Okay, combinedly, when we substitute case of this thing, your equation is formed like this. Okay. Okay. In terms of Q naught, you are substituting this. In terms of Q O dash, you are substituting this. Whatever the common factors are there, you are subtracting outside, means taking outside. Okay. Then like that way, QC by QH. Okay. That means QC to the QH. Okay. This reservoir to the this reservoir. Okay. So we have developed this kind of equation over here in terms of temperatures only. Okay. Why? Because temperature ratios have been given over here. This is like understanding the problem and deriving certain parameters like this, nothing more. Okay. So once you find this kind of thing, this if you put here TH by T naught and TC by T naught, these ratios have been given over here in the problem itself. Okay. So once you write small MATLAB kind of program, okay, and then you can develop this kind of plots. Okay. This is just for practice. You can write a small MATLAB program and you can take different ratios of TC by T naught. Okay, TC by T naught values are given over here for each TH by T naught. Okay, TH by T naught. One particular TH by T naught value you can take over here 2, and all ratios you will be substituting over here. Then this value you can get. Okay, that is only our plot. Okay, TH by T naught value here, QC by QH over here. Different TC by T naught values you are plotting over here. Okay, and similarly, this reverse phenomenon. In the x-axis, instead of TH by T naught, you will be taking TC by T naught over here. Okay, and this TH by T naught, you will be putting as the variable, different variable parameter over here, and then you will be getting this particular plots. Okay, this is only understanding about how this is working, and you will be deriving certain new parameter over here, nothing more. Okay, you can understand very well by reading this. So this is your third problem. Please read very carefully. This is a very simple problem from Sontag. Okay. So try to solve. Very simple problem it is. So these all problems actually involved with certain calculations only. Properties are not involved. Okay. That is the reason I have not solved this in the EES. Okay. So this is anyhow simple mathematical calculations. In problem number 5, that is problem number 5, 6 and 7 are very interesting and lengthy problems. Okay, and included with many properties of a particular whatever the working fluid. So for that actually I will show you even EES code also for that, and I will provide you also.
Sir, in this problem, like the whole 1000 megawatt is going to the water. Is it so?
No, here maximum steam temperature. Okay, and the pressure in the condenser is 10 kilopascal. Yes. But work output is given. This is the work output. Okay, this is the work output actually. This is not heat burning. Means this is not your Q1. This is work. Okay, and then hot temperature TH is given to you. TH, you know, work unit. Okay. So could you able to understand now?
Yes, sir.
Yeah. Okay, here electric power generating, okay, 1000 megawatt. So let us assume whatever losses and all, electric power means even mechanical efficiency losses would be there. Those are also, let us forget that. Whatever 1000 megawatts are there, that is coming from thermal cycle. Okay, and then higher temperature is given over here. The steam at 550 degrees centigrade, that is generating this much of work. That is TH. Okay. Now you should know TL means temperature of cycle low temperature or reservoir temperature. So pressure is given over here. Condenser pressure is given over here. Okay. Here let us consider over here. When we are impinging the steam upon the turbine and expanding to such a low pressure over here. Okay. So let us assume the steam is saturated. Okay. Now you can calculate this temperature from your steam table. Okay. Or otherwise simply in our EES you can write T2 equal to temperature, then open the bracket, steam, comma, okay, P2, P equal to P2, comma, X equal to 1. Yes, that command you know. Then you will get your saturation temperature. This is your saturation temperature. Okay.
Sir, how did we calculate this? Sir, I didn't
This
understand.
temperature.
Yes, sir.
So please go to any table, any steam table, open your any steam table, or otherwise I'll do in my ES itself, you can see. Okay. So let me clean this. Okay, do you able to see my ES? Yes?
Yes, sir.
Okay, let us consider P2 equal to 10 kilopascal, right? Then simply, so T 2 equal to temperature steam steam T equal to P2 comma X equal to 1.0. Okay, let me run. See, what is the temperature I got over here? 45.81. Yeah, that's what I'm telling. You no need to go table number 2. Okay, in our book, most book, our table number 2 or table number 3, you have to go. Okay, then you will be going over there. There you will be finding out, okay, for pressure of 10 kilopascal, what is the temperature? That way also you can see in the table. That is laborious process. Okay, so if you open your ES window, this is the pressure. We are considering it is saturation steam. Okay, then once you enter these all the things, you can get your temperature as 45.81. That is only the temperature. This is we got from there, from the table simply. Okay, either table or your ES. Now you know higher temperature as well as low temperature. Then we are applying over here reversible cycle of Carnot cycle. This is the efficiency, you know, 1 minus TL by TH. Okay, your efficiency is this much. Yes. Then you will be able to find out the similar way, you will be able to find out your Q minimum. So we have calculated here Q minimum. Okay. Then mass flow rate. Okay. Then mass flow rate. This is your thing is given over here. Okay. This is the volume. Okay. And then we are taking these particular things according to their dimensions. The flow rate is this. Okay. Okay. This is the speed. That way, the mass flow rate is 80,000 kgs per second. Okay. From these given dimensions and given flow rate. Okay. Speed it is given over here. So according to that, this is simply these dimensions and everything is to calculate mass flow rate of the water, otherwise nothing. This heat, whatever you have calculated, this is the rejected heat in the condenser. That rejected heat is obviously heating this much of the water. Yes? Yeah. So that we have equalized over here. Okay. This heat equal to M delta H. Delta H would be what? Cp delta T obviously. Okay. This is Cp. Cp of water, you know, 4.2 kilojoule per kg. Yes. And delta T, you know, okay. One is this temperature. Yes. Other is the room temperature. Yeah. Otherwise, delta T temperature difference itself you want to calculate over here. Temperature rise. Okay. So that way you will be calculating temperature rise. When you are discharging this amount of heat, the pond temperature will be rising this much. Okay. So when you want to keep this temperature as the constant, within this, whatever the pond or whatever, the same amount of water should be flowing continuously. Okay. So that is telling about this. Understood? If you have any doubt, you can ask here very clearly. So we are considering this cycle itself as the reversible cycle. Work we know and high temperature we know. Okay. Condenser pressure we know. Saturation temperature we are calculating from the table or otherwise a simple step, one step code in our ES that we are getting over here. Fine. Since we are considering this as the reversible cycle, so we have calculated your Carnot efficiency. Once you know efficiency in terms of the temperature, the same efficiency you can implement in terms of heat also. Okay, source heat we already with then we have calculated sink heat. Yeah,
Sir,
yeah, please.
Sir, the efficiency is work divided by the heat given But sir, here what we are doing is in this line that on which you are hovering, sir, like Q divided by work.
Yeah.
So like Q divided by work should not be like efficiency. Sir, efficiency should be like work divided by heat given.
See, this is the efficiency we are taking, right?
Yes, sir.
So efficiency equal to Q supply QH minus QC by QH. Yes.
Yes, sir.
Work itself is QC minus QH by. Otherwise, you can take in terms of work. Yeah.
Yes, sir.
Okay. Okay. Work upon your formula means in your pen paper. Hmm? Yes or no?
So like efficiency is work upon Q given, right?
Work upon Q given. Yes.
Yes, sir. So like work upon Q given should be equal to 0.6125.
Q given is not given over here, right? We don't have Q given.
Yes, sir. So like we have to calculate Q given.
Or otherwise, wait. Let me write another formula. 1 minus T C by TH. Similar way, equal to 1 minus Q C by QH. Okay. So Q equal to 1 minus Q C by QH. W equal to QH minus QC. And QC equal to QH minus See, this is like, let me write over here in your ES. Okay. So, F reversible equal to 1 minus TC, or otherwise T2 by T1. Do you agree? Here T1 equal to, let us, how much is this? 823. Okay. Here, let me change my temperature as the Kelvin. Okay. Okay. And T2 we are calculating over here. This is your efficiency. Efficiency, let me calculate here itself. Efficiency is 0.624, right? Okay, fine.
Yes, sir.
Pardon? Okay. And then now efficiency R equal to 1 minus Q C divided by QH. Do you agree for this? Okay.
Yes, sir.
Then,
Yes.
but QC we are calculating, QH we don't have. Okay. Then once you see work equal to QH minus QC, is it? Then Q, in terms of QH, we have to substitute in that same formula. QH equal to W plus QC. Okay. Then your EFF equal to EFF R equal to 1 minus QC divided by, again bracket, this QH W plus QC. Yes, sir. Fine.
Yes, sir.
Then you need to do these calculations. Finally, you will get that only. Now your equation is transformed into efficiency QC W. Okay. Here actually efficiency you know, W you know, Only thing is QC you have to calculate. Yes?
Yes, sir.
Then you can do it. Yes?
Yes, sir. Yes, sir. Okay, sir. I
Okay,
can
like
do
that,
this.
nothing. This is only calculations involving like that. Okay. Then what you will be doing? You will be taking, this is the common factor. Okay. LCM, then W plus QC. Then if you do these things, you will get it only. Nothing more. Yes. Okay. So this is that you can solve it. Okay. Then this is about problem number 3, and problem number 4 is also a very small problem. Okay. So let us discuss tomorrow. Okay. Yeah. Okay. Thank you.
Thank you, sir.
Thank you, sir.
So yeah, please practice well. I'll let you know all the information about the test, mode of the test, and other matters. Okay. Thank you.
Sir,